All right, what we're going to do is take a look at how to solve trig equations. This is part 2. These problems are going to be a little bit more difficult than the ones in part 1. And just keep in mind we're restricting our values from 0 to 2 pi. And when you solve these, don't forget about things you learned in Algebra 1 and Algebra 2. For example, if I ask you to factor 2x squared minus 3x plus 1, you would set up your binomials, 2x and x, and then you would look for two numbers that multiply to give me 2x squared, which is 2x and x, and then numbers that multiply to give me 1, which are just 1 and 1, but when I distribute the 2x and the x, they add up to negative 3. The only way this is going to be negative is if these are both negative on the inside there. All right, we're going to use the same exact concept when we solve this trig equation. So we're going to have 2 sine x times the sine x equals 0, and it's going to be a minus 1. Minus 1. And if you're not sure, FOIL this and check. It does go back to 2 sine x minus 3x plus 1. Now, since I have this term and this term set equal to 0, if one of them is 0 because it's multiplying, then the whole thing becomes 0. So we're going to take 2 sine x minus 1 equals 0, and sine x minus 1 equals 0. And keep in mind, this only works when it's set equal to 0. It has to be set equal to 0. Here we're going to add 1 and then divide by 2, so I have sine x is equal to 1/2. And if you look at, all students take calculus, sine is positive in the first two quadrants, and it's 1/2 at pi over 6 and 5 pi over 6. If we solve the second part here, we get sine of x is equal to 1, and sine is positive 1 right on the y-axis at 0, 1, and that is pi over 2. All right, so we have 3 solutions here: pi over 6, 5 pi over 6, and pi over 2. For number 2, let's look to rewrite tangent the sine of theta minus the sine of theta over the cosine of theta equals 0. And since I have sine in the numerator of both of these terms, this is a sine over 1 in the first term, I can factor it out. So I can factor out a sine theta, and I'm left with 1 minus 1 over cosine theta. All right, and now we have the multiplication of two terms, so I'm going to set each one of those equal to 0 and solve. So we have sine of theta is equal to 0, and 1 minus 1 over cosine theta is equal to 0. The first equation here, when is sine 0? That's when is my y value 0. That occurs at 0 radians and at pi. And then what we're going to do here is we're going to add 1 over cosine to both sides. So we have 1 is equal to 1 over cosine theta. And to make this easier, let's take the reciprocal of both sides. The reciprocal of 1 is just 1, and the reciprocal of 1 over cosine is cosine. So now I have 1 is equal to cosine theta. Where's cosine? A positive 1. That occurs at 0. So we have a duplicate answer here. So I'm just going to keep the 0 and pi circled. For number 3 and 4, they're the same exact equations. We're going to do them 2 different ways. For number 3, we're going to isolate the 2 secant theta. So I'm going to take cosine theta minus 1. We're going to subtract 1 from both sides. Is equal to 2 secant theta. And what we can do here is secant and cosine are reciprocals, and reciprocals, if you multiply them together, you get 1. So what we're going to do is we're going to multiply both sides by cosine theta. And what will happen is cosine times secant is just 1. So I'm left with just 2 on the right side. And if I distribute the cosine on the left, I'm going to get a cosine squared minus a cosine theta equals 2. And let's solve this for 0. So we're going to move the 2 to the other side. I'm going to get cosine squared theta minus cosine theta minus 2 equals 0. And this is similar to problem number 1. We can factor this now. Where is cosine theta times cosine theta equals 0, and 2 numbers that multiply to give me negative 2 and add up to negative 1. That's going to be a negative 2 and a positive 1. All right, and now we're going to solve these independently. We're going to get cosine of theta is equal to 2. We're going to get cosine of theta is equal to negative 1. Now cosine can never equal 2, so that's undefined. And where is cosine? Where my x value is -1? That occurs at pi. Right. The other way we could do this, I think it's a little bit more complicated, is we can get everything on the same side. So I'm going to move everything over to the, let's move it over to the left side. So we have the cosine of theta -1 minus 2 secant theta equals 0. We can rewrite this 2 over secant as 2 over cosine. So we have cosine of theta -1 minus 2 over cosine theta equals 0. And we can get common denominators now. And if we multiply everything by cosine over theta, and this is going to be cosine over theta as well, and the 1 I'm just going to write as, well, that's 1 over 1. I'm going to rewrite that as cosine over cosine. So we're going to have cosine squared theta minus cosine theta minus 2 over cosine theta equals 0. You can see that this problem actually sets up very similar to right here in the problem just before. You're going to get an extra solution here. What you would want to do is write this as, get rid of cosine and multiply it, write it as times secant theta. And it would just be undefined. So you'll get the same exact solutions as the problem before it. All right, but just two different ways to do the same exact problem.